Thank you, Peter, and the CARE Conference board for inviting me. I feel like we're going to go from the sublime to the ridiculous now. We started off with Keith's spectacular discussion of GE, and I always learn something when Steve talks, and it's kind of like big picture, highbrow. And you'll notice I'm going to talk about how to forecast sales at Starbucks. And I feel like the first year MBA student sitting in the room. But Peter told me that I couldn't actually talk about how my paper very much. I really only get to talk about that for 10 minutes. I have to spend 10 minutes talking about something bigger and broader because I'm one of the official old guys at the conference. So the only trouble I have is I really have no pearls of wisdom. I haven't learned anything in all my years, which is why I'm still trying to forecast sales at Starbucks. So I'll do the best I can, try to fill some time here. But then I get 10 minutes to talk about my paper, damn it, and no one's stepping out of the room then. So first of all, why forecast financial statements? I think the fact that you're here at this conference probably means you've agreed it's a reasonable thing to do, but let me brace you for some criticisms you might well hear. And these are criticisms that I have heard repeatedly. And so the first one is, who cares, right? Can't we just look at the analyst forecasts? So why forecast sales or why forecast earnings, right? We just go to the IBIS database, right, and look it up. And I suppose that's a reasonable answer if you don't actually care about where those forecasts came from. You just need, you're going to rest returns on something and you needed something, so use the analyst forecast. But it does beg the obvious question, how did the analysts do the forecast? And I just want to remind you that analysts don't actually fall from the sky, right? They turn out to be our students about 3 years removed. Right? I mean, do the math, right? Or actually go out and consult someplace, and you look out in the room, and you go, I recognize you. So, how the analyst does their forecast, particularly in a Reg FD, Sarbanes-Oxley world, is pretty much however we teach them to do their forecasts. And then they're going to go off to Morgan Stanley, and Trevor's going to teach them a whole bunch of new stuff. But that just, again, begs the question, right? How does he know what to teach them? So I think it's an area worthy of study because it's a vitally important task, and we can't just stick our head in the sand and say, oh, somebody else out there must know how to do it better than us, so it's not worthy of study. So related to the second point is, you're trying to build some model based on some publicly available information, but in the real world, the models are so infinitely more complex that whatever you're doing is just a waste of computer resources. And that could be true. That could be true. It seems like that's an empirical question, right? And if I get to my last slide, I can show you that it seems unlikely to be true, but at least in this context. But one, we could ask if that's the case or not, right? And then we would learn something. At least we would learn that, wow, at Morgan Stanley, they got these awesome complex models of forecasting, and we better figure those things out first before we try to improve on them. But another possibility is that it just isn't quite so fancy out there. And in the context of my little paper, Sarah and I were getting kicked around a lot on this paper and a whole bunch of different criticisms. And Sarah had kind of lost hope. She said, well, I guess it was just a dumb idea. Kind of give up on it. I have to get tenuring and then write something else. And then she absolutely went through the roof because she gets an email and then a phone call from the director of research at Goldman, some huge firm. I forget which firm it was. And the guy is just thrilled. He's found our little sales forecasting paper. He says they've been working on this problem, for quite a while in their firm, and they've got their own little model, but it's not quite the same as our little model. And he was just all excited about talking to Sarah about how to forecast sales in a retail firm. And so Sarah gets off the phone, and she calls me, and she's just screaming at me, right? That how is it that nobody likes our paper when the people in the real world seem to find it's interesting? And I just told her she just found the one dumb guy in the real world. Everybody else already had their big complex model that we would never understand. So, research. I too am going to stand here and plug the RAST conference and I guess the journal in general, because I think the editors fully embrace this question. And my only advice to you is that when you go to present your paper, be prepared for criticisms 1 and 2. Okay, so now why forecast sales? Again, I think in this room it's probably a reasonably obvious answer. It's like the really big number in the forecasting problem. It drives everything, right? Think about how we teach MBA students. You forecast sales magically, right? And then from that you forecast margins and you get income statements. You forecast asset turnover ratios and you get balance sheets. If that number is perfectly accurate, then everything else is going to be good that follows. Okay? So it's the huge first step. I do some kind of hokey math in a footnote of the paper to try to confuse you enough to get you to believe that a 1% change in your sales growth estimate can change your equity value estimate by about 15% in sort of some reasonable scenarios. Completely depends upon what's reasonable or not, I understand. But so like a 1% error is a big deal in sales forecasting, or it could have a big effect on equity values. So with that, what are we actually going to try to do in this little paper is just figure out how would we go about forecasting sales. And I wish I could say that this project grew out of some big, deep thought about accounting or anything, but honestly it didn't. It's like I teach this stuff. And every year I'm standing in front of these students and they're looking at me, how do I forecast sales? And I say, well, I don't know, what was sales last year? And then you look at all the rich detail you get from a retail firm in particular. They tell you, virtually every retail firm will disclose, we're going to open 14 stores next year and we're going to close 2, right? It's almost 100% of the time you'll get that in the MD&A. And they have all these press releases talking about their comp growth rates, comparable store growth rates. And they're simple. I mean, retail firms, at least the ones that work well in my model, are these nice, homogeneous units, right? So you would think if I could ever have something to teach my students about how to forecast sales, it might be for retail. So I just sat down with a big pad of white paper and started to think about what precisely would I do to forecast sales at a retail firm. And 10 years later, I've got this little paper. So that's what I want to talk about for my remaining 10 minutes here. So what needs to be modeled? Now, I'm going to apologize to actual theorists in the room. It's not a model. There's no agents choosing things. It's none of that kind of stuff. It's just a bunch of notation. But here's the underlying assumption: is that sales, and it doesn't have to be retail, but I'm just going to stick with retail. Sales are generated by 2 things: the units. So you grow sales because you have more Starbucks units operating, and because the sales at those units changes, or the comp rates change. So those are the 2 fundamental drivers of sales in this model. Now it's not completely a tautology because you can have internet sales, right? And that falls outside of my definition, right? Because it's not coming out of the Starbucks unit. And there's all sorts of assumptions you're going to see that couldn't be wrong as we roll forward. But that seems like the heart of the business in a retail. You can open new units, you can make more money in the existing units. Seems like the story. Also seems like a good way to go in retail because, as I said, half of the puzzle, the number of units you're going to open, is a really common disclosure. So like, what do I do with that? When the firm says, hey, we're going to open 12 new stores next year, how do I weave that into a logical forecast? The second half of the puzzle, the comparable store growth rate, is the hard one. And interestingly, firms rarely make forecasts about that. They might say in the next 3 months it's going to be a little higher, but I don't think I've ever seen an annual comparable store growth rate forecast disclosed from the firm itself. So this is going to be the hard part of the puzzle, or at least the part of the sales forecast that's going to generate the error. Okay, so my big model. It's actually not too tough, and I'm going to mercifully skip over that when it starts to get too ugly. But here's the story. I'm going to have 3 kinds of stores. New ones, so they're going to earn a sales rate per store of R, super in. I'm going to have these guys called mid stores, which are last year's new stores. Explain why we have to have them. And then I'm going to have old stores. So I got 3 kinds of stores, right, based on how long they've been around. So at this point, I still have a tautology, right? I can define sales. This isn't going to work. With all these T's on it, right? That is, if the number of stores I observe, that I know. But if I let the rate change every period as well, then I can always find a set of rates that will generate that sales, right? So there's nothing to be estimated or there. That's still a tautology. But it's a little bit more complicated than you might first think. So follow the store counts here and think about what the different rates are on the new, the mids, and the olds. So here's my story. First year you open 10 stores, okay? You don't have any comparable store growth rates or anything because you have nothing to compare to. You just opened them. Maybe you opened them on the last month of the year, in fact. Year 2 rolls around. So those 10 new stores are now the 10 mid stores. They've been open, right? They were opened last year. And maybe you open 5 new ones. You still don't have a comparable store growth rate, right? Because the 10 stores you opened in year 1 may have opened on the last day, right? They don't have a whole year of sales yet. So you got to wait till you get to year 3 before you can even do a computation. Year 3, the comparable store growth rate is simple now. It's the 10 old stores' sales for that period, compared to the same store's sales in the previous full year. So the olds to the mids, right? But if you look at year 3, something also is kind of interesting going on. Say you open 4 new stores. So you're sitting there as an analyst. You say, okay, here I'm in year 3. I got 19 stores for this company. Some of the sales growth came because I opened 4 new stores, and I'll have some estimate for how much they generate, right? And the firm will tell me that the comparable store growth rate was, say, 3%. And that tells me the sales growth due to those old stores at the bottom of the stack. But these guys in the middle, the mids, are kind of out of the story, right? They're not included in the computation for comparable store growth rate, yet they're not new stores this year. So why do I need to actually think about this more rigorously? Well, part of the trouble is the darn mids, right? They're not really covered by what you would naively think of, as the comp rate plus the new stores is the whole story. Well, it turns out it's not. There's this third category of stores that's going to mess everything up. And it gets even stranger when you roll forward to year 4. So year 4, I'm going to open 3 new stores. That's the easy part. And how many stores do I get to compare to? Well, I've got these 15 old are going to earn at some rate in year 4. But I'm going to compare them to these 15 back here, right? Well, but these 15 back here could be earning at different rates. That is, this mid rate might be, say, not fully mature yet, right? It might be the same earning rate as a good, old, well-developed store. So what we end up with is just the definition of comps. No assumptions here yet. Just the definition of comps, comparable store growth rate, is a little bit more complicated than you might have guessed. And this is the ugly expression for it, right? It's a big messy thing up here. My point is, it's only when I ignore the mids, I say they're instantly old stores, do I get a growth rate that looks like this thing down at the bottom, which you probably would have thought, oh, that must be what comps are. They take the existing old stores and they see how much their growth rates were. But in fact, the mid stores in the proper expression also have an influence. So here's tying this back to class with a Home Depot case. So I teach this Home Depot case. And through the roaring sort of 90s for Home Depot, they were growing like crazy. And if you looked at their statistics, you would see comparable store growth rates of like 12, 13% year after year after year. And now literally, if that's true, you're thinking it's getting really crowded in Home Depot, right? I mean, if the same existing stores are giving 10% more people in them every year after year, it's going to be standing room only, right, in Home Depot. And that's not actually what's going on. What's happening at Home Depot is they're slow to mature stores. And so as they're opening new stores, this denominator, those M's, are earning at a less than fully mature rate. So the denominator is depressed, and it makes the comp growth rate look bigger than it really is. Right? And so as Home Depot is opening stores like crazy, their comps look crazy because some of that growth is actually just maturing of the store. Right? But you would never, until you actually stopped and got out a pad of paper, I don't think you would have sort of fully appreciated this. So Home Depot stops growing, all of a sudden the comps plummet. Right? So way back when, Richard was, this is going to be a great short strategy. We're just going to wait for their sales to turn down a little bit, and we're going to short Home Depot, and we're going to make $1 million. And he probably did, but
just a couple more minutes.
Okay. So where are we going with this? We actually have to estimate something. So let me skip ahead a little bit to the answer, which is this guy. Okay. So now I actually want to estimate sales. So the first thing I'm going to do is I'm going to estimate the change in sales so that I get a nice stationary thing to estimate, right? And I'm going to do it firm by firm, of course, because Walmart and Starbucks are quite different sizes, right? They're not going to have the same earning rates. So now I'm doing estimates on an average of 12 observations. Okay, so just keep that in mind. I got 12 observations in a regression. What's the big thing in brackets? Those are my independent variables. And I can walk you through the notation, and I don't think it's not actually all that complicated. But let me just loosely say, what I'm going to do is I'm going to use the fact that I know there's a predictable change in the earn rates, those comp growth rates, right? To control out all that variation in the earning rates and bake that into my independent variable so that I have something stable to estimate. So what's going to come out of the estimation is the R sub capital T, the earn rates in the most recent period, right? But I'm going to estimate, and that thing would be changing, right? But I can use the known variation from the comp disclosures to control out that source of change so that I get something stable to estimate, and then the independent variables hold all that moving stuff. Okay. So the point here, the slightly deeper point than how to forecast sales, is that by spending a little bit of time with a blank pad of paper, I get a really nicely specified regression. Right? And I don't think you would have just thought of that if you just got up one morning and said, I want to forecast sales. I think at least you got to give me credit for an honest day's work. Okay? This was not the most obvious thing to arrive at. Now let me show you what we end up with then. So I'm going to skip to the results. I've got 3 different versions of this crazy model. The crass empiricist result, come on, we're accountants, right? We run regressions just for the fun of it. So I don't know who I want to pick on. The crass empiricists out there would say just regress the change in sales on the change in stores, right? So I'm going to call that ad hoc model. And we would hope that my careful reasoning model would beat the ad hoc model. And you must know it's going to, because otherwise I wouldn't be standing here, right? So I've got a sample of firms to do the regressions. The model fits remarkably well. Remember, 12 observations on average in a regression, and we get a R squared of something like 92%. Okay, and things are significant, all that kind of stuff. If I compare my forecast error, so I'm going to take the error in the numerators, right, the residual on my change in sales, then scaled by sales, so it's all as a percent of sales now. In sample is about 2.5%. Just this first model one is the only one I really care about. Okay. If I just run a regression, I get one of these bottom 3 models, depending on how I specify the regression. So I get error of almost twice as big. And these look like small numbers, but remember 1% error is about 15% different in my market value estimate, right? So I would say we're talking about real money now. So observation 1 is we do better by thinking than we do by not thinking. Okay. Now the second question, and I was going to gloss over this, and then Steve brought it up in such a powerful way, I had to admit that, well, in sample fitting, we're all really good at that, right? But this is a forecasting exercise, so we really want to know how well we do out of sample. So here's some example. Let me skip to the answer. Well, out of sample, so now I'm going to estimate those rates, and I'm going to use only 5 years to estimate the rates so that I got some years to forecast out of sample on. If I have perfect foresight of the inputs, that is, I know for sure how many stores are going to open, I know for sure what the comps are going to be, okay, then my error on the lead model is 2.39%. So like that's the best I could do, given that I have to estimate those rates. Okay. Now, how do I actually do? So I'm actually implementing this so that I could really have a forecast of sales. What would I really tell my students to do? So I take the store's disclosures about the number of stores they're going to open, and I have a model for what the comp rates are going to be. And it's basically just a mean reversion model on comps, mean reverting into rate of inflation. How do I actually do is 3.79%. Okay. So, you know, still better than the in-sample fit for the ad hoc models. But the final graph I want to say is how well I do compared to those darn brilliant analysts out there that are, so, sophisticated. And so if I take the analyst forecast error on revenue for pretty much the same time period, like 9 months before the realization, the analyst's absolute error is 3.2%. Okay. So you can say, well, that's way better than my model, but I don't think so. My model, I'm armed with 5 years of historical data, and that's it. Okay. And they get to actually talk to Keith, So I think there is something to be learned by trying to forecast and sort of do this stuff rigorously. And we don't have to just say that, oh, the analyst model is so much better than ours, we've got nothing to contribute. So Sarah sent off this graph to the guy at wherever he was at Goldman, and we never heard from him since. So, okay. I think I'm
2 questions, repeat the answer.
All right, questions? I beat you into submission. Trevor.
So, given the work you've been doing, is it going to change how you teach?
So has this changed how I teach? I mean, I'm really a practical guy, right? So very specifically, absolutely. I've got students with Excel spreadsheets running these little regressions. And the next thing you have to teach students is they don't all fit, right? I mean, I had a pretty good fit, and on average, 91% R-square, but
So now I want to give you my follow-up question. So why would you think that an analytical may be overstatement, an algebraic model with a regression run with 12 observations would be the approach as opposed to looking at taking the logic you're using, just applying it in a less systematic and more idiosyncratic way, where you actually try to understand the stores, go deeper, which is really what fundamental analysts try to do. Why do you want to fit it into a statistical
right.
framework?
So the question, I think I'll get this right. The question is, why do I want to actually estimate these rates and fit it into this sort of structured model, as opposed to like one step back would be to use the logic of the model, but then bring in a richer source of inputs. Is that fair? And I think that's a great point, and that's why I can spend more than one class session teaching this stuff. But the way it plays out for me is they're running their regressions on all their little firms, and one of them goes, oh, my coefficients are negative or whatever. And so I said, well, okay, maybe we should think about it now, and where does the model leak, or where do your inputs leak? Right? And the model can leak because they've got huge sources of revenue that are unrelated to the stores, or it could leak because the estimates are just really crappy. They went from big stores to little stores. It's not really a homogeneous regression anymore. So, I completely take the point. One
One other question.
Russ, why do you care about the number of stores rather than the size of the store? And instead of thinking about square feet?
Yeah, no, that's it. So DJ wants to know why the number of stores and not, say, the size of store. So what I need is a homogeneous unit, right? Think of it just from a regression perspective, right? I need these things to aggregate well. So Starbucks is a great example for my model because most Starbucks are very similar sized. But the model doesn't actually work very well at Home Depot because there's really big Home Depots and there's really little Home Depots and there's expo centers, and I'm treating all of those as one unit. So the more complicated answer then is remake your notion of what a unit is to be a square foot. And actually for Home Depot that works much better. So yeah. Cruise ships is another example, right? You can study cruise ships or you can study cabins. Turns out cabins is a much better modeling unit than, or berths, I guess they call them. But, all right.
Thanks. Thanks a lot.
Thank you.